So now we are going to start with the topic that is hard water and soft water. Water that produces soap radially radially is known as soft water. For example, rainwater, distilled water and demineralized water. Remember, rainwater is a soft water. We sometimes get confused with the thing that rain must can be containing some pollutants and all, but yes, it is a soft water. Then we come to the next, and that is hard water. Hard water is that water in which soap does not produce leather radially. For example, sea water, river water, spring water, lake water, and well water. Remember, well water is not a soft water. Sometimes we think that the rain water is a drinkable water. It has no minerals, the pure water, so it might be soft. No, but it is a hard water. Now, the hardness of the water is due to presence of bicarbonate, chlorides, and sulfates of calcium and magnesium in it. Calcium and magnesium ion react with the anions of the fatty acid, stearic, palmic, oleic acid, etc. to form a curdy white precipitate. As a result, the leather is not formed immediately. For example, the sodium stearate combines with calcium chloride to form calcium stearate with a curdy white precipitate, and NaCl is there. So the precipitation is occurring and soap is not giving the leather. By types of hardness. Hardness is of two types: temporary hardness and permanent hardness. Temporary hardness is due to presence of bicarbonates of calcium and magnesium present in it, which can be removed by boiling. With permanent hardness is due to the presence of chloride and sulfate of calcium and magnesium, which cannot be removed by boiling. Now we come to the next topic, and that is removal of hardness of water. The temporary hardness can be removed by boiling when bicarbonates of calcium and magnesium decomposes into calcium ion and magnesium compound. They removed by filtration and water is rendered soft. Then we come to next method of removing temporary hardness, that is Clark's method. In this method, calculated quantity of lime is added to the temporary hard water, which magnesium and calcium is removed in a soluble compound form, that is calcium carbonate and magnesium hydroxide. Equilibrium of this reaction displays forward due to the formation of insoluble PPT. Excess of lime is to be avoided, otherwise the precipitation will take place and this will be not a pure or soft water. Then we come to the permanent hardness. Permanent hardness is due to presence of chloride and sulfate. The first method, soda lime method. In this method, what we used to do, we used to add sodium carbonate. The calcium sulfate is converted to calcium carbonate. It's precipitated. Now no more reaction to the anions of soap. Then same way we come to the next method, and that is Clark's method. Callaghan's method. Callaghan's method is also known as sequestration or masking method. In this, what happens? The salts are masked by Callaghan, that is sodium polymetaphosphate, NaPO3 whole X, where X is as high as 100 or more, commonly with the sodium hexametaphosphate, whose trade name is Callaghan, is used. Complex Ca+2 Mg+2 ions do not form any precipitate with a soap, and hence the water is radially producing leather with a soap solution. Then we come to the next method, it is ion exchange method. Ion exchange method can be of two types. One is inorganic ion exchange method and organic ion exchange method. And inorganic ion exchange method is again of two types. This is anionic and cationic. Same way, organic is cationic and anionic. Same. In case of inorganic, a permuted, that is, or zeolite, naturally occurring, and permuted is synthetic resin, which is sodium salt of lead, where lead is aluminium silicate. Aluminium silicate, hydrated aluminium silicate is treated with sodium and to form this, and this exchange is taking, and then the calcium is not free for forming precipitate with the anions of soap, and the water is radially producing leather. Then permutate is magnesium, is calcium magnesium zeolite, calcium and magnesium. It can be, however, regenerated by passing 10% of NaCl solution through it. Then organic ion exchange method. This is the best method used, superior to the zeolite, and since it can be removed by both cations and anions present in the hard water. Now, calcium ion exchange method. Calcium ion exchange method, we can take carboxylic acid, which is reacting with calcium and forming a calcium carboxylate, and then again the calcium is not available to combine with the anions. And same way, anionic exchange method, we take the alkyl group, and alkyl group combines with the anion, and which is not again available for the forming cardioid prepity. So best method is organic ion exchange method, and reason behind it can be used as both removing cation as well as anion from the water for purity of the, or for making this water soft or producing leather.